Welcome everyone to Reuters Events' latest webinar. Today we're going into the wind power market and with specific focus on North America. I'll just wait a few minutes to let some of the attendees join. So bear with me for 2 minutes. Thanks. Okay, great. Well, I think we're ready to start. So, yeah, everybody, welcome to the latest webinar from Reuters Events as part of our January series. So this is the last one of the month. Today we're looking into North American wind power specifically and linking O&M data to financial engineering for maximizing wind power asset value. And I'm conscious that we've only got an hour, but if there's any audio problems throughout, just send a message in the chat and I'll get on fixing it. But today I'd like to introduce our speaker, which is Gareth Brown, CEO at Clir Renewables. There was actually two speakers from Elemental Energy and Silver Peak that we did bring on last minute, but unfortunately, with scheduling issues, they couldn't make it today. But we've in plans to do a sort of a short Q&A about the subjects that we'll be putting out. So everybody who signed up will get a copy of that as well, which is good news. So yeah, last from me before I introduce Gareth. So just so everybody knows, this webinar is in conjunction with the Wind Operations Dallas event in April this year, the 16th and 17th, which connects experts, industry leaders to discuss the core challenges in operating, maintaining operational wind farms in North America. And for this year, we're sort of breaking that down into strategic asset management and technical O&M. So there'll be a lot of information about that coming out for after the webinar. So keep your eyes peeled for that, and hopefully I look forward to seeing everyone in Dallas. So yeah, I'd like to introduce Gareth. If you can unmute your mic, Gareth, and I'll change the screen.
Hey, there we go. You're able to see my screen okay?
Yep, all good.
Great. We'll shrink this down here. Hey folks, yeah, so great to be here this morning. I'm just based here in Vancouver, British Columbia. Actually giving two presentations today. This is my first one. The second one is at my eldest's school. So I'm being presenting on wind farms to eight-year-olds this afternoon. I'll let you guys work out which is more daunting there. But anyway, yeah, I really appreciate the chat today to basically speak about maximizing financial returns on wind assets here, specifically in North America, but also more broadly as well. Just to tell you a little bit of background about myself for those on the line who I haven't met before. Originally, I worked in consultancy, so I joined as an independent engineer doing wind resource assessments and then turbine technology, due diligence for financing, M&A, and then operations. So joined a company called Clir out of Glasgow when they were a startup in 2005, who became part of Wood Group, but yeah, I had the chance of working extensively in Europe and then heading out to China, India, Sri Lanka, and then 2009 they sent me to the Americas to build their operation over here. So I ended up having staff kind of on the independent engineer side from Chile to Canada, but decided to kind of stop working in the consultancy space to start working in the software space at the end of 2016 and the start of 2017, where we founded Clir. So we're a company who wants to kind of minimize humankind's impact on the planet. Kind of our niche is turning renewable energy data into action. So say we started beginning of 2017 with no product and no team, and then we've grown to about 6 gigawatts around the world, but the bulk of that being here in North America and Europe. We really come from the data science side in renewable energy, so expertise particularly around just optimizing wind farms, and we've recently moved into solar as well. Yeah, so what we do and what we only do is provide a software platform in the space. So we provide a SaaS-based model where people subscribe to our cloud-based AI platform to understand the technical financial risk on assets, so they're able to optimize their returns. So there's kind of 4 main pillars around that. There's kind of asset health, there's increasing the output of your asset when it is running and healthy. And there's the the financial engineering side, which I'm very keen to talk about today around that, which to increase your financial returns, you don't really need to produce more power. You need to manage risk better, because renewable energy is all about cost of capital on those assets in the first place. So if you manage your technical risk and understand the risk around your asset better, you're able to get better financial returns. And then the kind of last main pillar of the software platform is enhancing the domain expertise, that kind of knowledge and transfer within the companies that are using the platform, but also their ability to kind of work with external partners as well, and getting that feedback loop throughout the end users there. So yeah, and like I say, on those, like I say, just really quickly cover kind of what Clir does. On the asset health side, we're looking at kind of two main areas there. When you're looking at an asset, one, you're looking at is the wind turbine about to have a heart attack? Has it got signal, vibration, temperature signals coming off there that indicate something is about to go in the kind of near term? But it's also looking at the future. What is the diet of that wind turbine? Have I got a turbine that's built for a sprint, but it's running a marathon, or vice versa there? So we want to see, with the platform, is really assess those kind of loading conditions the turbine's under, to understand if it's going to last 20, 25 years, 30 years. Then say on the AP side, say this is, as an industry, we've been really focused on availability, asking the question, is the turbine spinning? But what we should be, being better at as an industry is asking, am I extracting as much energy as I can, rather than just question, is it spinning? So looking at all the availability issues and optimizing for that, but then also looking at leading edge erosion. Is the turbine pointed into the wind? Have I got poorly defined control parameters on my wind turbine, which is costing me energy and money there, to minimizing my kind of financial returns. So it's an example here of kind of a yaw misalignment, where you've got two different power curves on the same turbine there. Turbines don't keep perfectly up with the wind. If they did, they would burn out the yaw motors. So what you have is a natural lag on wind turbines, and you can see that when it's lagging on wind turbines, that actually it's increasing the output of the wind turbine. So the kind of normal distribution here is shown on this interface here. You can see that the orange is the peak when it's aligned with the wind, or when it thinks it's aligned with the wind, but actually when it's lagging behind, because you have this natural hysteresis, it's actually increasing the output of the wind turbine. So that lag is actually the realignment of the wind turbine. So you actually want that distribution sat over that 8 degrees misalignment in that case. So having tools that allow owners, operators, investors to just understand what is going on to optimize them there. Say the technical financial, which I want to talk quite a bit about today, is dealing with the, where do these technical inputs fit into that financial engineering, the ability to do energy yields anytime, all the time, not having to do one-off assessments, but then feeding that back through to your financier if you have debt on the project, tax equity, or whatever it is, so you can actually have a dynamic and risk assessment on your output going forward. You can actually increase the leverage on your assets to increase the output. Validating any upgrades. You might be thinking of putting a widget on your wind turbine or whatever it is, or having a tool which makes it trivial to kind of assess these things. There's the whole questions around life extensions, sweat the asset harder, or repowering as well. So being able to understand from the data in a kind of trivial, automated way what is going on there. And I say on the OEM and the operator side, being able to basically make sure that you have alignment with them, and they're doing not what's in the contract, but say doing what's in the contract, but they're also aligned with getting the most out of the asset. And then say on the financial side, a big aspect that we're seeing more and more in the market is folks wanting to understand this risk in the M&A phase. So folks packaging up and selling assets, but also buying assets as well. So being able to use these kind of risk assessments in there. I can say the last one I'll just hit on here is the domain expertise. So one of the big challenges we see in the industry is the siloing of everything going on between companies, within companies, and everything else. So building a software platform that allows you to get that feedback loop and that understanding across the business without having to employ 10 data scientists assessing things in there, or getting those turbine engineers, those data scientists focused on the outcomes and fixing things rather than just manipulating the data. So where we are today is, today we want to talk about the maximizing of the asset value. I think it's a huge topic in the industry as we're getting more and more mature and going forward. And say we do a lot of assessments on this within Clir, and what we see is that there's a lot of money being left on the table by not managing our technical assumptions, our technical risk well. When we look at the performance of the assets that we have across our fleet, we're at about 6 gigawatts right now, but in the team as well, we've worked on tens of gigawatts of assets there. When we look at the issues that go on technical risk, we kind of see that there's 22 billion by the end of 2022 across the wind and solar space, and really fixable issues which should be managed there. And when you look at the risk profile on debt provisions, on lenders and how they structure those, on the risk profile on these assets, if we were just better at quantifying risk, we could get these premiums, the costs associated with these items down by 40%. So we think there's a huge opportunity, but the reason this stuff hasn't been fixed is, it really isn't easy. So there's kind of 6 core challenges that we see in the marketplace today. I used to work for a Scottish firm, so I kind of, some of my colleagues will laugh at me putting up this image here, but we kind of go on with like if you don't measure something, you can't improve it. That's really one of the fundamental challenges in the wind industry today. It's the only power source in the marketplace where you have undefined inflow conditions. So when we go to a nuclear plant, a coal plant, a hydro plant, we have a pipe going to that turbine. We have that turbine in a fixed, controlled environment, so we know how much energy or how much resource, if you like, is going into it, and we know how much power is coming out. In the wind industry, you know, we know how much power is coming out, and then we have a little cup anemometer or ultrasonic behind a very large blade on top of a tower, which is trying to define what the rotor plane inflow conditions are, which may stretch over hundreds of meters. So inherently, this is a much harder problem to understand the technical risks on a wind farm than it is from a resource perspective than it is for other resources in the power industry. And it's why there is this opportunity out there as we go forward. So when we look at the resource conditions of, when we want to get O&M data coming in and we want to understand how our asset is operating, it's really, really important. It may sound blatantly obvious here, but it's amazing how we run our assets in the industry today. It's the wind. We need to have good understanding of what's going in. So you've got your SCADA, your CMS, which may measure loads, which is, you have a couple of anemometers, you may have loads on the blades, you may have a meteorological mass at the site, and you may have them off-site as well to kind of extend out the kind of reference periods there and really explain the kind of regional variations there. But the other point is, as I come back to, you don't have that pipe, so you don't know what's going to turbine. What you do have is what drives the inflow conditions. Like your wind turbine should know where its neighboring turbines are, so it knows when it's being waked. It should know where steep slopes are around your site, and it should know where forestry is, because these things really shape and drive the form of the winds that are going into your wind turbine. And your wind turbine should also know where water bodies are. I say, we talk about the blockage effect as a big topic in the industry, but it's atmospheric stability. It's how is the atmosphere mixing at your wind farm, and if you begin to capture these geospatial considerations in there, then suddenly your SCADA data coming out, your power performance, your measurement of wind speed on the turbine have a lot more context, and you're able to pass out much more accurate results there. The second big challenge that we see for getting good financial optimization from the technical assumptions there is really overly simplistic turbine design. I mean, it's incredible where we've come as an industry in such a short time. Like if you go and read the design standards in the industry today, the IEC or anything else, and you look where a lot of the assumptions have come from, in those design standards, design standards, a lot of them came about from a very clever, probably Danish person in the 1980s and the 1990s came up with some really novel approaches at the time. The problem that we have as an industry is the wind turbines of today are not necessarily very reflective of what they were at that time. So we're putting turbines up in parts of the atmosphere that we haven't put before. We're putting up much larger machines, much lighter machines for their size. And it's very hard to always move the design standards forward because we need everybody to learn and everybody to get consensus, because it's an industry consensus approach, and it takes a long time, and that causes problems today. And we see that even just in the data model that we get from wind turbines. Like I say, bringing in the inflow, bringing in the SCADA data and everything else, you need to integrate that information together in a data structure which is able to get to the answers that to get to the financial performance answers that you want in a kind of trivial way, again, so you don't have to employ 10 data scientists to look at your fleet for months and months and months to get one static answer. You should be getting these answers back in kind of near real time as you go forward. So even if you look at like basic SCADA data coming off a wind turbine, we really took the data model from the rest of the power industry, which is typically one or two turbines in a large power plant, when what we have in the wind industry is hundreds of turbines scattered over a hillside, all with different inflow conditions. And to analyze that and to get to these answers, what it's been historically is a non-trivial thing to do, but fortunately, with the cost of computing and storage of data and everything else over the last few years, if we use smart approaches to our data model and restructure the way that we deal with that data, we can suddenly get to these answers in a really straightforward way. So on that simplistic side, one of the very unique things I say in the wind, so having so many assets out in a field, like even on a typical wind farm in Texas, you might have 100 turbines spread out over a large area, is that data's changing all the time. So if you're trying to understand technical risk and you have a data source that isn't static, it makes it a much more challenging issue. So for instance, if I connect into a wind farm of one OEM type, if I connected in to get yesterday's data today, I might find that only 50% of that data is available right now because those turbines are still buffering back to the main SCADA. If I go and access that and yesterday's data in 2 days' time, I may find that I'm set 75% of that data is available, or in a week's time it's 90% of that data for the same time period. And then on top of that issue of data coming in late, you've then also got the OEMs are going in and relabeling that data, the service providers. So they're doing that over extended time periods. The owners are going in and relabeling that. They're changing it. They're splitting it. They're and all the time, when you want to get these outcomes, you've got to rerun your machine learning. You've got to rerun your AI. You've got to deal with this fluid data structure, and it means that historically, we really haven't had the tools to be able to update energy yields really quickly, update the technical financial risk. So this has been a big challenge in the industry for us to address it as we go forward. And then dealing with this fluid data and changing all the time, and the simplistic design, we have to change the way we deal with the communication. You need the data, the same data, if you like, in many forms. Like if I'm flipping the asset for M&A, I need those raw files. The independent engineer doesn't want something that's been manipulated or changed. That they need to have access to that. But you also need but say with that backfill issue and everything else, you may want to kind of bring those files to the most recent version of that together there to kind of streamline that process. You then, if you're assessing optimization or asset health or life extension or any of the optimization options there, you also need that data in that reformatted sense. So you're able to if I have a Sanvion asset, a Siemens asset, a GE, a Vestas, whatever it is, I have that common data model that I'm able to query, understand across all my OEMs types, because the OEMs are really, they have very similar data structures, but they're different, and it makes it a challenge to understand these things. And then I say the last stage that you want is access to that full enrich. So when when the machine learning, the AI has buggered about with all of the signals coming in and clean them up and come out with predictions, you want to get access to that enriched data as well to understand what the optimization potential is. So there's all these different stages of the same data that you need to be able to communicate with the OEM, to be able to communicate with IEs, but also then to understand your asset as well. And it's been a challenge, I say, with a lot of operators in the market when they're going to kind of speak with a lot of owners in the market or insurers or lenders there. It's important that we're using a common data set, but for the specific need. And then reiterating on the kind of overly simplistic design in the industry, I say a lot of these design assumptions I said came about from some really smart people over the last 10, 20, 30 years, but the industry is changing so quickly. And what we need in the industry is to be making sure that we understand the assumptions that went into the design of the turbine, and then understanding the assumptions that went into the design of that wind farm. Because if we do that, we can then go and challenge the assumptions once we're in operation. So having a platform that understands site conditions, the curtailment strategies, the dynamic control, which I mean by pitch and yaw, the static control from high temperature, from shutdown control of that turbine, the wind farm control, how it interacts with the grid, and then the assumptions that went into the technical financial side, which I say really drive the value on the financing of that asset. So if you get these assumptions together, you challenge them, then you're suddenly able to drive much larger returns in the asset by saying, is it doing what it's supposed to be doing, the asset, once it's in operation, but also is it doing what's optimal? Because I say these wind turbines are designed to this idealized conditions of the wind, and then we go out and put the turbines at the site, and actually the real world conditions are dramatically different from those design conditions there, which give you a chance to, one, optimize the asset to increase output or extend life, but also protect the asset. Like if you have risk that you want to make sure that you mitigate as you go forward. One of the kind of the third big challenge that we see in the marketplace, which you need to have a strategy around to address, is the conflicted nature of service providers and OEMs. And this, some people would argue that aspects of this are deliberate. So some of it is just in the way it's gone. It's not anything intentional there. But we have taken this data set from these kind of wind turbines, which is taken from other power industries, and it isn't necessarily suited to the wind industry, because we have all these extra unknowns of inflow conditions and many turbines scattered across a site. So what we need to do is create synthetic data to basically deal with that data model and fill in all those gaps. So again, you can quickly get to the answers of, is my turbine pointed into the wind? Have I got risk that actually my site is more gusty than I expected there? Can I optimize my icing and control? So having this kind of synthetic data set there on top of that allows folks to understand. We need to understand the kind of limitations of the data coming off these wind turbines in that kind of raw form. And then talking about the kind of conflicted nature there, I mean, just keeping in mind that most of us are signing, really the only guarantee you have on a contract is there's availability. It might be an energy-based availability there, but it's not making sure that turbines are pointed into the wind. It's not making sure that it's driven towards optimal output. So kind of what you need internally is the tools and the strategy to be not just working to the contract, but you're keeping in mind what is optimal for your farm as you go forward there, like dealing with all these performance issues when the asset is running, which are typically really excluded from any performance contracts in the industry as standard. Say reporting, I can't emphasize this enough. I mean, how many operators do you go into and see, well, I know what my wind speed is, I know what my availability is, and I know what my production is, and I can do a little bit of outage assessments and things like that to kind of get availability up. But what we need in the platform is to understand all of the kind of derates, the partial performance. How much energy am I losing to leading edge erosion? How much energy could I gain by felling some trees around my site? How much energy am I losing because turbines don't point it into the wind, and I don't have an easy way of assessing that because of the data structure and tools that I have. So the conversations that we have internally as a business tend to be shaped by the reporting and the KPIs that we use. I say historically this has made sense because we haven't had the computational power to get these enriched data sets and everything else to have a more informed conversation. But over the last 5 years, that has just changed dramatically with the kind of the cost of cloud computing coming down so low. Talking about cost, this is a thing, like people go, oh, great, I can buy some fancy AI, pay a fortune, and hope it pays off. And I kind of emphasize again that it's a bloodbath in the market right now. We saw GE's profits last week or earlier in January. Anyway, we saw, I think on the data analytics side, I've seen, and this year I've heard about 2 or 3 firms going under. On the service provider side, I mean, it's so hyper competitive there. So renewable energy has got, it's incredible where the pricing has gone. And I say with any of these tools and strategy, it's got to be iterative. It's got to be innovative, and it's no good coming in with $1 million solution without having the good understanding of value there, and also ideally just coming in at a low cost. Say just talking about where that pricing is. I mean, I'm always amazed with the different contracts that we see internally, and also hearing about it internationally as well. The last thing I'll just hit on is the kind of 6th challenge that we see for kind of getting these kind of big financial returns on assets is those silos. I mean, we're still an incredibly young industry. We've been around 10, 20, 30 years. If you've been in since the 80s, the M90s, you're probably a CEO or a big director at a big firm, just because I'm sure all the folks on the line are awesome at their job, but there hasn't really been a lot of expertise in our industry. I know when I started out fresh out of school to 2005, suddenly I work hard, I do a good job, I'm suddenly being sent to India, I'm being sent to Sri Lanka, to India, working on for the World Bank on financings of assets, working on underperforming assets, and a lot of that is just driven by the expertise. And what we see in companies, what we see in consultancies and everything else, is you tend to get folks who know how to develop a wind turbine, or you get folks who know how to develop a farm, or how to finance a farm, or run a wind farm, or buy or sell assets at the end, or do that end of life planning. And it's just getting the feedback loop throughout those groups, which really drives improvement. There was kind of one company I used to work with, even getting the kind of meteorological groups sat next to the turbine side guys, and linking the kind of turbine performance issues, with the kind of wind issues that we're seeing at site there, it ended up getting large improvements in the assets there. And the next thing I'll hit on in is lack of it. Is, does anyone really have big data? I know, the big players will say I'm 10 gigawatts plus, I'm 15 gig, and we have some of those 15 gigawatt clients we're working with, and they label the data somewhat internally, like they put it in context so they can begin to use machine learning, but is it really done that well? And then like the biggest players and the OEMs have got like 100 gigawatts of assets that they've sold, but the OEMs have taken a strategic position that they haven't built SCADA systems in place that get the feedback from what's actually going on site. I mean, you'll see a lot of the data streams coming in will be pause pressed on keyboard, and the wind turbine was going to shut down for 2 or 3 days. Was it a turbine inspection? What was it a gearbox issue? That context on that data isn't there. And today, I really challenge, who really has data in big data that's in context. And we certainly see as an industry that we haven't really got there yet, and that's part of why in building Clir was something I wanted to do with our co-founders here. So I'm going to talk now a little bit more specifically about maximizing asset value and where that fits into the life cycle. So when we got our pre-construction phase, we're talking about the design of turbines, but specifically the farms. Then we've got the financing side, the debt, the tax equity, the kind of M&A, buying pre-construction assets and everything else. And then we've got the operations. So we want to understand the asset to optimize and prioritize. We want to be able to to validate upgrades and be able to do more informed power curve tests on input performance there. Insurance, and I know insurance over, let's say, is bloodbath in people building turbines, bloodbath in O&M. I mean, the insurance market, if you go and look at the underwriters today, I mean, these guys are getting absolutely hammered. They've been losing money in renewables hand over fist, as it's been really a race for market share. There's been folks who've been wanting to get in and underpricing the market. That isn't going to carry on going forward. The prices, any of the operators on the phone have already seen that those prices are coming up dramatically there. Part of that is that there does just need to be a correction there, but there is also a part of it whereas when you look at how risk is being assessed by the insurers, because of the operators, if you like, from a legacy perspective, it's a really hard thing to assess risk on a wind farm asset because of the challenges that I just outlined before there. And there's basically a huge amount of potential there to be lowering our kind of insurance costs, the financing, the debt, the tax equity, the kind of M&A side, managing their risks so you can get more favorable terms. There's the M&A side. So what I've definitely see is is folks wanting to manage what is the upside potential on buying the asset, but even selling the asset. Like quite often you can justify the longer life in term sheets for the financial model, but also you don't have to always implement all the optimizations. You just have to demonstrate that they're there for the buyer, and if you can give the evidence for the buyer to be convinced of that, you can then drive up the value of your assets. And then lastly, hitting on that kind of question of how to run your asset. Do you want to do a life extension? Do you want to sweat it and make it drive harder? So particularly projects on PPAs or shorter term contracts, with the market pricing, it's basically collapsed. So running the assets harder in the short term could be a really smart financial decision for your asset, rather than looking at extended life. And then comparing to repowering, you've got all this data for this operational asset. How do I put a different turbine and technology on that site and assess it? So coming back to those kind of 4 areas and where they tie into the strategy that you want to be implementing internally there. We look at asset health, as I said before. You need to be looking at the current side. It really impacts the insurance. It impacts your availability for the year and your planning around O&M. So being able to pull the temperature data off the CMS, any other sensors there on oils, and continuous oil sampling. But also looking at the diet of the wind turbine. I say this is something which a lot of operators are missing, is like, how gusty has your wind farm been? I mean, your wind turbines have been designed to these idealized conditions, but is it really at that kind of mean wind speed? Is it been exposed to those gusts, those extremes, that air density? Being able to bring all those parameters in a really automated, trivial way will then drive what kind of optimization that you can do going forward, because there's extra flexibility in the asset going forward. And then how many sites should you go out and recertify for a longer asset life if you have that information on the mechanical loads going through your turbine? So like optimization, just hitting on that point, increasing, it's the most obvious one for increasing the kind of value of your asset, to just produce more kilowatt hours. So if you get those challenges addressed, and of getting the data in context, restructured, labeled, then suddenly looking at your misalignment, looking at icing strategies, looking at forestry felling, looking at wake effects or wake steering, it becomes a much more trivial exercise to do, because the data is already structured in that context, that you can ask the questions that you want the answers to, rather than conducting science experiments internally. So on the technical financial risk, I mean, one of the big changes that we've seen is that lenders and other investors are open to moving towards dynamic terms in their contract. So rather than investing and saying, hey, or lending on projects and saying, hey, look, here is my p-values on my energy yield, they'll actually allow it to be assessed continually as you go through, as long as the risk profile has been well defined there. So having dynamic predictions around this is key. Upgrade validation and OEM kind of validation as well. So you often see different widgets being offered on projects to kind of increase the financial performance, whether it's putting LiDAR control in place, putting widgets on the blades, or even just doing blade repairs, or and basic maintenance there, and proving out that those things have made a big step change. Being able to break out the kind of different wind conditions that are driving underperformance there from the mechanical or the electrical improvements that you've put on the asset. This should be a very straightforward in process. You can get those financial returns there. Power curve tests, I say, I don't know how much value everybody gets out of doing these at times. I mean, they're pretty, they're pretty much passed in most cases there. But one of the things that you'll see in the marketplace right now is people will go out and test 3-4 wind turbines at their 100 turbine site. But in fact, those turbines are getting a lot of close attention, and they're running in a way which isn't reflective of the rest of the turbines at this site. So having a good strategy in place that makes sure that when you're testing wind turbines, you're doing those kind of full power curve tests, that you can make sure the pitch, everything else on your other wind turbines is really behaving in a similar way, and they aren't just being souped up for the test. It's usually outside the scopes of the power curve tests, and being able to kind of check that in a trivial way will drive up the financial performance of your site. End of life assessments, again, I hit on the asset health there, that kind of feeds directly into this. OEM operator oversight, say there is a conflict of interest in the contracts that you sign from service providers, typically around availability. It's not about maximizing the kind of kilowatt hours and the financial pro forma for your asset. So having tools which aren't being given to you and shaped by the thought process behind that contract, but having tools that are being shaped around that financial return of the asset. Even things like energy-based availability. The only reason I put that in there is it's just so like it's in January time. They're being paid out on many projects right now. Even energy-based availability. Most of these calculations are agreed at the pre-construction phase by a bunch of lawyers and smart engineers in a room who come up with a really novel approach of calculating it, which is really interesting and great theoretically, but implementing it in real life is a huge pain in the ass. And and then at the end of the year, you have to pay out millions of dollars of bonuses. Having a tool in place which is able to, or a strategy in place to make sure that calculation is being done, validated, and checked, where you're not requiring two folks to go off for weeks on end, and ideally you're addressing that bonus payment halfway through the year, every quarter, every month, in a really automated way. It's huge to drive that value on those assets. And then lastly, just hitting on the M&A, the insurance, the kind of debt side, all these things are feeding into how those terms and structures are done as you go forward. And I emphasize, this is the real driver on financial returns on the assets is the cost of capital. So looking at how long is my asset going to last? Can I optimize it? And and looking at all of the different risk aspects around it. And then knowledge management, which I think is I've got a startup here. I've been doing this for 3 years. Taking the company from kind of 2 staff to 50 staff. Like communication, even the silos in our business is a huge challenge every day, and definitely seen that in the industry as we go forward. I emphasized before, getting the meteorological group sat with the mechanical turbine group. Gave large improvements for a 5 gigawatt plus holder here in North America. Just getting them sat together, communicating well, and understanding the issues. And the same applies to the technical financial risk. If you can feed back on what the issues are on specific technologies, you can make sure that you design the next wind farm better. You can make sure that you finance it with better assumptions, with better terms. So we like a quick example. Like most people in financing, pretty much turbines are all the same. This is a great example of dynamic fuel. So this here is 6 different OEMs and how they track the wind, how they keep up with the wind. And what you can see on this pale blue line here is this is one turbine type. It's lagging behind the wind. It's letting the turbine go 8 to kind of 20 degrees behind the wind before it realigns itself with the wind. While a really well-controlled wind turbine here is plus or minus 4 degrees. This has really significant impact on the output of your wind turbine. So understanding when you've got Siemens, GE, Vestas, all these things, and being able to bring them into a platform where you can compare and contrast the real performance of these assets for normalized wind conditions, you can then begin to look at that pre-construction projects and be like, hey, actually this turbine will outperform this other technology over here, but also on all of the other losses, electrical losses, wake losses, power curve performance, all these aspects. And then feedback. So it applies heavily internal, but also applies external as well. You know, we had one large OEM here in North America who our platform was kind of used with a client. They were able to get a yaw misalignment item fixed. The same OEM service team in the UK said, "Hey, this is voodoo magic. I don't believe anything I'm getting here." So being able to connect those owners, getting lessons learned outside your company, I would just emphasize how much we kind of see the kind of same issues occurring again and again. So having a tool that allows you to connect with different companies with similar platforms around the world helps us accelerate those issues getting fixed. Yeah, so that's kind of Clir's viewpoint on maximizing kind of financial returns on wind farms from a technical standpoint. Thank you very much, and I'm happy to answer any questions.
Great, thanks a lot, Gareth. That was a really in-depth sort of look and talking about the key challenges and sort of the strategies to combat them, and obviously maximizing asset value. Really interesting. We've got a few questions, but please, guys, send some questions in now. We've got about 5 to 10 minutes left. So just one that's come up was, I think it was in regards to one of the challenges you were talking. I think number 6 they've said it was. What else do you think we can do as an industry in terms of preparing for the future workforce in regards to your challenge number 6?
Yeah, I say you get people stand up in conferences saying that we need to share data, we need to share information, all these things, and these folks are hyper competitive. So you know, there's not a lot of interest of doing those things, of sharing knowledge and everything else, unless the business value proposition is there. I come back to, like, you know, we like it here at Clir, we don't give folks challenging sharing data if the business case is there. And I say those lessons learned, getting folks involved. I do think that CanWeir and AWeir have done a reasonable job of, like, you know, preparing the workforce as we go forward. And I think part of this is patience as well, that it does take time to kind of drive forward. But I say like, the thing that I'm excited about most at Clir is being able to connect the different users with kind of shared issues. So for us, it's like, if we present the issues, the opportunities in front of them, and quite often, you know, people are fixing yaw misalignment for the first time. They didn't know about these issues. Having tools that are describing problems that they've never seen before, and that have always been there on their wind farms. That for us, it's been about building out knowledge bases, making sure that our customer success team are not software folks, but are actually turbine engineers, and, you know, finding that unicorn of a really good engineer who, I'm an engineer, by the way, child engineer in the UK, but an engineer who can communicate really, really well and happy dealing with client problems is, you know, it can be hard to find though. But yeah, come back to specific points. I say the industry organizations is a key way, but building these tools and structures that allow the different parties to interact on specific problems rather than just generic let's share data.
Okay, great. So just quickly as well, moving on quick because we've got a lot of questions coming in now. Kim asks, do you think the push to certify wind turbines by NREL and other organisations correlates well with the performance of large populations of wind turbines in the field?
Yeah, I think we need to focus on, like, certification. I just emphasize it as a minimum bar. Like, I think certification is good. I know some OEMs, I think GE, for instance, will design to the certification, but perhaps are not going out and getting full certification. I think that, you know, that's a completely valid approach, and it gives more flexibility in their business line. But I think the certification, I still view it very much as a minimum bar. Like, you still need to look at the wind conditions. I mean, you look at, you know, the design standard, when they get certified, they don't look at things like shear and distribution. They don't look at in distributions in general, they tend to deal with averages and assumptions around distributions. So certification is great as a first, but when you design and run your wind farm, you need to look beyond the assumptions that are in there, because they're often things that came to consensus 10, 15 years ago and are not what is best practice today from what we've learned.
Okay, great. And just some clarification Paul's asking for in return to the start of the presentation. He said that it was cited there was a $22 billion loss due to optimization and other factors. And he was wondering what the origin of the number was.
Yeah, I'll be honest. I think I put in there that it's Clir's view at the start of that slide. I should double check. I know I tried to basically put that in. So basically, Clir assessed. Okay. I did our own internal. I didn't put that there, so I apologize. But I thought I put that there earlier. But it is Clir's assessment of optimization. So you can take it with a pinch of salt or anything else. But you know, we're seeing underperformance of really fixable things across and the kind of fleets that we work on and have worked on.
Okay, great. And sort of like a future thinking question as well. Christoph says that you mentioned that wind was the long hanging fruit for this type of solution due to its inherent characteristics. However, have you looked into applying this to other types of generation, such as hydro or gas?
Yeah, so we're applying it on the solar side. I mean, gas is an interesting one. I mean, I come back to, like, you know, the values of the company and sustainability, and I know view gas is clean or don't, but I say we've been offered to work in other industries. It has to really drive with our values. So I think that as a company, we're working on solar now. Hydro, I look at the complexity, the fact that the industry's been around for 100 years. You design a hydro plant today, designing it 40, 50 years ago, that design probably hasn't changed a huge amount, although I shouldn't pretend to be a hydro expert here. But solar is an area I've worked on extensively as a consultant, and we have a lot of expertise in the companies. So we expect to be, we're already launching our solar, kind of a soft launch on our solar product. But yeah.
Okay, great. And William asks, how do you use data like this to quantify the reduction in maintenance costs due to improved scheduling and reduce unscheduled maintenance events? Would that require a longevity of data that doesn't yet exist?
Yeah, no, I agree. Like I say, like, you know, we always quantify. I come back to our values here, impact. You know, we're always trying to do these internal assessments on impact. If I find a fan is broken on a wind turbine and you know, a gearbox isn't being cooled, and they fix that, you know, is that fixing of the cooling on the generator, you know, is it saving six months or 12 months? It would have broken. Would that have been fixed anyway? So I think, you know, inherently there's a lot of value here, which is fundamentally hard to quantify. But there's other aspects like your misalignment, where you're increasing the output of the turbine, that you've got understanding of life extension assessments, energy yields, which have comparable consultancy fee costs, that doing the kind of return on investment assessment there is much easier to do in certain areas than others. And I'll be clear as well, I don't think on some cases there'll ever be the sets of data there. You know, when we run a machine learning algorithm to detect, you know, how a gearbox is behaving, and we learn and everything else, and then it fails. And it's not like they put the same gearbox in every time. They put in a brand new gearbox which vibrates and cools down and heats up in an entirely different way. And then we need to see that gearbox operate under the whole range of wind conditions and temperatures again, to understand how it should behave. And ideally, you know, we're putting in components which are getting better and better all the time. So everything that you learned historically doesn't necessarily apply going forward anymore. This is the nuanced thing about AI and machine learning in industrial applications. Is, you know, it's not like a Google or a Facebook. And anyway, I'm probably going off topic here, but yeah.
Great. Okay, thanks a lot, Gareth. Yeah, I mean, I think you mentioned as well in the presentation that it's so valuable having such like an international and global representation from different stakeholders, or sharing the data as well, which is of interest. But unfortunately, that's all we've got time for today. But I appreciate you taking part, and everybody who attended. I hope it was valuable. and all of the recordings have been shared, and we'll distribute them on Monday, so you can share them with your colleagues and look back at any of the information, and or you reach out to Gareth directly. I'm sure he'll be keen to answer any further questions. So, and with that, I mentioned earlier as well that it was in conjunction with the Wind Operations Dallas event that we're hosting in April 16th, 17th. So hopefully I look forward to seeing some of you guys there in Dallas, and we'll be sending out some more info about that for you to sort of grip your teeth into and have a look at what's going to be discussed. So thanks a lot for joining, and again, thanks Gareth for your expertise and your insights.
It's great. Thanks, guys.
Thank you. Cheers.